Thank you, everyone. Thanks for joining us today. My name is Yogi Rampuria. I'm a solutions engineer at Yugabyte. And if you have any questions, please go ahead and ask them in the Q&A box. I'll be keeping an eye on that one. Um, all right. So, hello, hi, Raidu. So, today's topic that we have selected is YugabyteDB, a turbocharged PostgreSQL. Before I get started, I would like to really appreciate an excellent job that the artist has done in putting together an excellent turbocharged elephant, which obviously is a Postgres symbol. And I'm really happy that we are embracing the whole Postgres ecosystem more and more. So with that, if you're new to Yugabyte, Yugabyte is a multi-model distributed SQL database. Primarily, we support Postgres and Cassandra flavors of SQL. And we'll be learning a little more about Postgres side of things today, and hopefully we'll cover more on Cassandra on a future webinar. My name is Yogi. I'm based in Singapore, and I've been with Yugabyte for about 2 years now. And in my role, I actually speak to a lot of partners, customers, prospects, and even open source users across the world. Open source users across the world, but of course, partners and prospects more in the ASEAN region. And in my travels and in my journey, I always come across this key question: how compatible is Postgres? How compatible is Yugabyte with Postgres? And most of all, what advantage does it have over something like a Postgres? Will some certain feature work on Yugabyte better, or it will be same, or what are the trade-offs that I have to do? And with this webinar, the idea is to actually highlight some of those aspects and make you curious to learn more. So today, what we are seeing is that due to a lot of changes in the market, in the businesses and the way we operate, there has been a tremendous change in the entire IT ecosystem. We started out with infrastructure and application modernization, where we started using virtualization and cloud more and more. And then we moved on to an application modernization phase where we adopted microservices and application frameworks to build amazing user experience. Now, we are at a cusp of actually something new. What we have seen is, although we have modernized our database, modernized our infrastructure, we have modernized our application layer, but database typically tends to be a bottleneck in terms of resiliency and scale. Hence, all the things that you are able to supposedly achieve with these microservices, you are not able to fully utilize and fully scale as per your optimal framework. And this is where the modernization question of database comes in. Now, what we have seen as a trend in the world over is Postgres is a highly matured ecosystem, and its popularity is only on the up and up. Every vendor, every cloud provider, every database provider is leveraging on Postgres or Postgres API to actually benefit from the large ecosystem. We recognize this, and what we have done is we have actually internalized the Postgres better than anybody in the distributed SQL world. How we have done it? Let's have a look. So first of all, of course, we love using Postgres. Right? We've adopted it. We've used it line for line, code for code, and we've actually made it simpler to manage. Just checking on the Q&A. Okay. So no more Q&A. I'll answer the slide, and this is done. Okay. So how are we doing what we are doing? We learn through a series of slides and a series of demos that I have put together to understand this deeply. All the content that I'm sharing today, including the slides, are actually published. So you'll be able to actually get a copy of these anytime in future. All the demos are actually placed on GitHub. We'll go through how you can actually leverage cloud to run them and run the demo yourselves. So what is Yugabyte? YugabyteDB is a distributed PostgreSQL for business critical applications delivered as a flexible service. You're able to actually leverage our SaaS service, our self-managed DBaaS service, or most of all, our open source database to actually build your own service. This YugabyteDB eliminates the most common limitations of Postgres around clustering, resiliency, scaling, and it actually simplifies your application architecture by providing a seamless experience across your entire cluster without having to work on the application side in recognizing or trying to do manual sharding or something of those types. And this is what we built in what we call as a database modernization capability. Now, if we look at Postgres, which is a single node database, now it provides what we call as a local low latency execution, but it cannot provide you with the distributed execution. Fast forward to about mid 2015s, and we saw emergence of distributed SQL, which sort of had limited local execution, actually nothing to begin with, but it was really good at distributed execution, which actually provided it with the resiliency and the scale. Now, with these two sort of, two different vertexes or two different poles of computing, you want something that sort of brings everything together. You would want the low latency execution as well as the resiliency of node failure together. And that is exactly what YugabyteDB brings together today. We are able to actually provide low latency local executions and resilience for smaller workloads. And we are able to provide distributed execution and latency at scale, distributed execution at a scale with resiliency for larger workloads. And this is what YugabyteDB sort of brings together. Now, in terms of compatibility, we have tested Yugabyte with a lot of open source Postgres compatible applications. This you can see it has quite a few open source tools that you use day in, day out. It has a lot of software development and management tools that you do use. Apart from this, of course, we have also tested it with other commercial products. But today's webinar is more geared towards our open source heritage. So in all, the entire experience of Yugabyte is just like PG. To actually go through this, what we did was we used Mastodon as our sample application, which has a fairly complex schema, and this is something that requires a global scale. Now, Mastodon, if you're not familiar, I'll come to the Mastodon part in a bit, but before we go to that, let me just sort of set the stage for the Postgres heritage and Postgres familiarity and similarity of Yugabyte. Now, in case of Postgres, you have a client application that connects to the Postgres. So this is a single server Postgres. If we look at its internals, it has a query layer on top, which comprises of about these 5 major components. It has a postmaster, which sort of takes care of posting the query to the lower layers. The rewriter, which basically rewrites your queries and creates a plan against it and sends it to the executor. Now, over a period of time, the planner and optimizer, they sort of work together and provide better plans to the rewriter. And whatever is the plan is being given to the executor, where it leverages 2 levels of storage in the storage layer. One is the wall writer. This is where whenever you're writing something, it first goes to the wall writer, and then a background writer, which would actually take the wall and persist it into the long-term storage. And this is all working against a disk or maybe a set of disks. I mean, these disks could be a single JBOD or a direct attached storage, or it could be like an external storage. But all these things are running in a single server. As a result, any change that we are doing is confined and limited to the single disk or single system or single server, unless you actually replicate it out. Replication is typically only and only meant as an asynchronous activity. It's not synchronous. So that thereby it actually gives you the risk of a non-zero recovery point objective between something being written to the disk and it being replicated. Whatever is the lag, that becomes your risk. So in a system with 1000 TPS, if you lose, let's say, 1 minute worth of data, you lose about 60,000 transactions. In a system with a million TPS, 1 second loss results in a 1 million transaction being lost. So at scale, this problem can be actually quite devastating. Hence, the complete rethinking of the storage part and sort of extracting out the query layer. So what we recognized at Yugabyte was the query layer in Postgres is extremely good. It actually provides us with a lot of capabilities that also enables us to leverage on the larger ecosystem, whether it is for management tools, whether it is for queries, or whether it is for integrations. The query layer of Postgres is really powerful. And what we have done is we have reused this query layer and we have retrofitted it with our storage layer connectivity. So our storage layer is a modified version of RocksDB. If you're not familiar with RocksDB, RocksDB is a key value store based database, which provides you with a distributed storage capability. Now, this is extremely good as a storage unit. It is not appropriate for a highly transactional or transaction-oriented application where you might have multi-row transactions and likes of those. But we could use it as an underlying storage for a transactional query layer. And that is exactly what we did. So as part of the storage layer, every table that we create in, say, Postgres gets converted into its equivalent sort of a store or a document store in the RocksDB, the storage layer. The read-write consistency over the network, distribution of data, load balancing of data, that portion is actually managed by the RocksDB layer that we have. This database layer doesn't, this document store layer doesn't require any special hardware. It is able to run on any local disk, external disk, direct attached storage, or something of those lines. So long as we have fast enough storage, this layer is able to work just fine. And the query layer was retrofitted to leverage on the APIs of this storage layer, which is a RocksDB layer. Let me just quickly check if there are any questions. Feel free to actually ask questions when you have them. So in the theme of, just like PG, let's actually look at a very short demo where we've taken this Mastodon application, which is actually built against Postgres, and migrated it into Yugabyte without any code change. Though it's an open source application, we did not make any code change in the Mastodon application itself. And we saw that the performance was at parity with Postgres. So let's have a look at this demo. So this is a Mastodon website where it obviously has gotten a lot of popularity over the years due to the nature of privacy and some of the changes that have happened. The source code for Mastodon is completely available online. You can go and audit it yourself. You can actually use it to deploy a small scale social network, a private social network. And it has a very lean sort of requirement. It doesn't require too many things. Now, this is what it looks in practice. You have a database at the back, and then the Mastodon front end talks to the backend, and it actually shows you all the messages that have actually been done. Now, I'm running the first copy. Let me just take this 1 second back. I am right now running this against an RDS, which is a 40 48 core. Yeah, 48 core RDS database running in US West 2A. And what I did was I ran this against the Mastodon application. Now, obviously, we created the configuration and everything around it, and then ran the sorry, just give me 1 second. Yeah, and then ran it against that database. Now, what we have also done is we have created an equivalent YugabyteDB with 48 cores of CPU, but instead of one node, we are using 3 nodes. So each node is about 16 cores each, right? And in terms of RAM, we are leveraging about 32 GB RAM per node. And so like for like, we've tried to use the same configuration, try to run everything in the same sort of locality in terms of the cloud to see what is the difference or if any we get. So now here I'm using a replication factor of 3 so that I am able to sustain a single node or a single zone failure. I'm using just 3 nodes, so there is like 1 node per zone. And my total vCPU, as I mentioned, is 47, which is same as the 12x large on the AWS RDS Postgres. Now, having done this, what I do is I actually first log in into the YSQL shell, and I create a simple database called Mastodon. Now, I use an optimization called collocation because Mastodon is a relatively small database. So we use that optimization for actually creating the database. So going back, yeah. So we use the co-location capability of Yugabyte, and then what we do is we have a file. It's empty. There are no tables in here. I have a file called Mastodon schema yugabyte.sql, which I dumped from the Postgres, and I ran it against Yugabyte. Now, when I run this, all my tables and everything is created. Then I use a Docker-based deployment of Mastodon, and I use the rake on the Mastodon and setup command to actually make it, to bring up the Mastodon and connect it to the Yugabyte database. Now, over here, obviously, it says PostgreSQL because Mastodon doesn't know that it's not a Postgres, but it's actually a Yugabyte. But that doesn't make any difference because we are not changing anything on the Mastodon side. The only change that you might see is instead of using the regular Postgres port 5432, we use 5433 Postgres port. Now, having done that, we actually, this is the database name, this is the username, and that's the password. And then we like within a couple of minutes, the website is up and running. It creates the schema and everything that it requires. And what we can see is inside this, we have all the tables and indexes that we want. Now, so far what we did was we were able to actually create the database and the indexes and everything that was required by Mastodon without any change. Now, next, what we are going to do is we are going to actually run a simple performance test to, let me check what's the question? Okay, so we have quite a lot of the question that we have on the Q&A is one of the strength is on the extensions, and yes, we recognize that, and right now we are on PG11, so we actually support the PG11 extensions. In fact, a fair number of those that are there, we actually support them out of box. Some of the critical ones like UUID, JSON. JSON data type is actually baked in, foreign data wrappers, things around Oracle, Aura FCE, which is a very, very common extension. We actually have it pre-bundled. And apart from that, we always work with the open source community for variety of extensions that are out there. So the next question is, for what OS does Yugabyte use? Yugabyte is fairly OS independent. It can run on any flavor of Linux. We ourselves validate this on Ubuntu LTS, RHEL, and we used to be big on CentOS, but what we have done is we have now adopted Alma Linux as our baseline. On cloud, you can use Amazon Linux for deployment. There is a question around, is this a subscription based? So we have a fully open source offering that you can just download and use without any subscription. However, if you use our enterprise service, which is like a software as a service, that's a subscription, and also a self-hosted DBaaS, that's also a subscription service. No, we don't support Windows today. We only support Linux or Linux-based operating systems mainly. We don't support Windows-based installation. So going back to the demo that we were at. So out here, what you can see is all the tables that were created. Now, what we do next is we go ahead and start a load testing on this. So we are using a tool called Locust, which is a very popular load testing tool. Here, we are going to simulate about 100 concurrent users, and they will sort of, start at 10 users per second. Now, in this setup, on the top, you see the YugabyteDB website, and on the bottom, you see the Postgres SQL-based website of Mastodon. So we are running this simultaneously. They are on two different machines so that they don't interfere with each other. But the Locust sort of window on top is the PostgreSQL window, monitoring the PostgreSQL workload, and YugabyteDB workload is at the bottom. So, I mean, yeah, while I was recording this, I sort of recorded it the other way around. So just bear with me for that part. Let me just quickly take the question. Because sure, Aldo, I would. So the biggest difference between Yugabyte and the EDB distributed is EDB distributed actually leverages the BDR capability of Postgres. Now, bidirectional replication, although it works, it's still not a distributed storage. It is still an asynchronous storage. So because of that, there is a non-zero RPO even for the distributed. All right. No, we don't. We are not. We are not deployable on a Windows server. You could use WSL for like testing and non-prod, but you can't deploy Yugabyte on Windows, and that's primarily because some of the capabilities that we use are only available in Linux kernel and not available in Windows. Yeah. Although you might find you might be a Windows engineer, you will find that setup and setup of Yugabyte on Linux is fairly straightforward. It's like just about extracting a package, and if you use something like Docker, then it becomes a single Docker command. Yes, yes, Lucky. We do have Docker images available. In fact, in the demo and in some of the workshops that we have, you can actually see the Docker images available. And all the instructions for running a multi-node cluster with Docker and all the instructions are actually available on our documentation. All right. So again, going back to the demo, what I'm showing you here is on top, I am running the workload for Postgres and the monitoring, the load testing monitoring for the PostgreSQL backed Mastodon. And on the bottom, I'm actually showing the Yugabyte backed Mastodon. Now, once we run these tests to the end, what we see is just in a few minutes, after running for a few minutes. Now, first of all, if you look at the right out of the gate, what you see is, although Yugabyte is a distributed database, it's running on multiple nodes, you are still able to get almost the same level of response times from Yugabyte, which is distributed running on multiple nodes. That means the data is present on multiple nodes versus the single node Postgres. In some cases, it might be slightly better, but in most cases, we find almost the same latency. So this is one important thing. So even though you are actually adding multiple nodes and moving the data across multiple nodes through auto sharding, you don't actually incur as big a latency due to network. So Aziz has a question on whether it is available only for enterprise. No, we are 100% open source that you can just download and use Docker, Kubernetes, or like our Linux distribution. Okay, going back. So let's look at some of the key charts here. Now, one of the things that when you're running a large scale web application is how many requests per second am I able to do, right? So over here, we've actually kept 100 concurrent users. So every second, it's both of them are sort of giving us the same per second response. So if you look, consistently, Yugabyte is actually working consistently because we put like a 10-second head start, right? So every second, it's actually sort of spawning 10 more connections and then like going for the user requests. So it's able to do about 60 requests per second. So that is comparable between Postgres and Yugabyte. There is no difference, even though it's running on multiple machines. The second thing is the response times. So here we see that not just the number of requests per second that is getting fired, but the response time, average response time in terms of milliseconds is comparable or even better in some cases. So this is another thing that you would like to gauge. So that was a very, very simple demo of how Yugabyte is able to work just like another Postgres. Now, typically, when you are actually building a large scale website, what you tend to see is not just like thousands of users, but maybe, multi-hundred thousands of users concurrently. Now, that typically every user sort of equates to a new connection being formed. So if you have used Postgres, one of the key challenge that it has is around concurrency, the number of concurrent connections that it can actually handle. We have our heritage in Postgres. So obviously, we also had similar limitations. So there's a question in the chat for how about hardware specs? Do we need a high server to install Yugabyte? It actually depends on the kind of workload that you're going to put. If you're going to have a very read-heavy workload or a write-heavy workload, and how big of the data size is going to be, depending on that, you will have to size your nodes. Now, typically, our recommended sort of production node size is about 16 vCPU, but for some of the smaller workloads, you could go down to maybe about 8 vCPU. Anything below that, we don't recommend because of the distributed database having to do the data distribution and monitoring, network monitoring, and all those aspects. So anything below that can be quite challenging and will have a negative effect on the overall stability of the system. So like the smallest footprint that you would have is probably about 8 vCPU, but 16 vCPU is what generally we recommend. In fact, our internal test, we tend to do on 16 vCPUs. And also the benchmarks and everything that we do is done against 16 vCPU nodes. All right, so going back to the connection. So what happens is when you are not able to have high number of connections, your website, your workload will actually feel sluggish. So one of the challenges, how many concurrent connections can you do? The other one is how fast can you create them? So what we have found is some of the capabilities that we have baked into the Yugabyte in recent versions, where we have enhanced over and above the native Postgres and embedded a connection pooler inside the database itself, so that you do not need to actually maintain an external connection pool. So this is a typical server-side pool, right? So that actually enhances the overall experience of concurrency. So let us actually look at a very short demo. Again, the front-end application is Mastodon, but now we are actually concentrating more on the concurrency aspect of it. So in this demo, you would see that
we've got a great demo to showcase our new data.
So in this demo, what we will see is how many concurrent connections can I have and how fast they are actually spawned. And it's overall, like, compared to, let's say, an equivalent Postgres that we had earlier on the RDS. So we've kept the, again, same exact configuration that you saw earlier, 16 vCPU per node, 64 GB RAM, and it's all deployed in the same zone to actually keep the results comparable. To keep the results comparable. So if I just sort of fast forward a bit to this, so this is what we sort of saw, that every sort of connection that gets created in Yugabyte is about, I mean, at scale, at like high numbers of concurrency, it's about 20x faster than the equivalent Postgres. And that is because of the new connection manager that we have actually introduced. So that creating the connection, number of connection faster, plus like more number of connections is also something that we are doing better than the regular Postgres compared to the RDS Postgres. Let me see what's the question here. Is there a native migration tool? Yes, we do have a migration tool called Voyager, which you can leverage for migrating live from Oracle to Yugabyte. It's like recently the live migration has actually been introduced. Okay. Are the client connection connect to single node or any node? With Yugabyte, the client can actually connect to any node. We do not have the concept of a master or write server and read server. All the nodes in the YugabyteDB cluster are actually equal and they are peers. And an application is able to connect to any one of them and read and write. So at minimum, there's a question on how many number of nodes to install best practice Yugabyte. Minimum, you need about 3 nodes to actually run Yugabyte in a resilient manner, because of being a distributed system. You keep 3 copies of it. You lose 1 copy also, your application continues to work. Okay. When you said scaling, the Yugabyte should have container for scale out or just directly Linux OS on another node. So we should prepare the port communication each other. Yes, correct. Whether it is container or whether it is a VM or whether it is a bare metal, the idea is exactly same. You want one more node of Yugabyte, you actually create one more node. The node itself is container or a VM or a bare metal. And yes, you should be able to do the internal RPC connection, which is a well-defined port. You need to be able to do communication over that port. Can you share how the query gets optimized execution plan when SQL runs on any node? Not in this webinar, but I do have a live demo that you can actually refer to later. I will put the link in the GitHub repo, where you can actually go and see the query tuning workshop that you can leverage for tuning it. We also have an excellent course on Yugabyte University to go and try query optimization. There's a question on, does the app also have to be multi-AZ with YugabyteDB? It's not required to be multi-AZ, but if you think from an architecture perspective, it should be, right? Because your database is running on multiple availability zones. So that database will actually remain up and alive But if your application is only running on a single availability zone, then you have a problem. Because if that availability zone goes down, your database is up and running, right? It's able to respond to queries, but there is no application to respond to. There's no application that connects to it and tries to get a query response. Connects and capacity. Yes, you are able to actually scale the disk as well as scale out the compute and disk both. You are able to do both those things. So, for example, if you have a DAS or a external SAN, you add more capacity to it. You would actually use the same, like the traditional tools of Linux to scale the file system for it. And once you have scaled the file system for it, that becomes like any other tool, right? If you're using our enterprise offering, a lot of it is automated. So if you're scaling the disk, it goes and talks to the cloud provider or Kubernetes to actually scale the disk for you. Is there a kind of replication like example CDC? Yes, we do support CDC just like Postgres, and we have like connectors. We use a Debezium based CDC. So any system that can actually consume Debezium CDC, you are able to connect to Yugabyte and get CDC in. Similar, yes. There's a question on, are we following the same method as Cassandra? So in case of Cassandra, you typically go to a zookeeper to actually find out the nodes. In case of Yugabyte, you don't need to do this. We have a driver called Smart Driver. We have it available for Go, Python, Java, Node.js, and .NET, where it can actually resiliently connect to one or more nodes to find out the entire cluster and topology, and then keep connecting to them in a resilient manner. So you do not need a load balancer. If you're not able to leverage the smart driver, then yes, you will need a load balancer in front for a resilient sort of addressing. But at runtime, Yugabyte itself doesn't require a load balancer. As AZs are several miles apart, is there a latency seen when communication between? Yes. So your underlying AZs, they will always have some level of latency. The idea is Yugabyte is actually compatible with that kind of latency. So it is able to actually connect. It is able to put nodes far apart across availability zones and able to deliver the service without any downtime, even though the availability zones are far apart. Yes, it's able to sustain that. When you said it is possible to outscale capacity, which node the external storage should connect? All nodes should connect, or only one can connect to the external storage? So Yugabyte uses a shared nothing architecture. So every node is independent. It's compute, it's network, it's memory, it's storage. Everything is independent. So we do not use a shared storage architecture. It's a completely independent storage architecture. So ideally, you would have your DAS, which is a direct attached storage, or a JBOD, or an external SanDisk connected to each node. So you will not share the same storage across multiple nodes, because I mean, that becomes a single point failure if we share the storage. You can use DAS, you can use external storage. We don't actually support NFS kind of storage. It should be a block device if you come from the Kubernetes world. So yeah, it should be like a block device. It's possible to have different capacity on each node. So there is a question on whether we can have different capacity. It's possible to have different capacity, but we don't recommend it, because the problem there is if a node goes down, it becomes difficult to actually replenish that, right? Because you don't know how much of capacity you lost. So the best practice is to keep all the nodes identical. The question is, does it support secondary indexes? Yes, absolutely. Partial indexes, secondary indexes, a ton of indexes are actually supported. Yeah. And I'm sure we have about 15 minutes now, so I wouldn't be able to go through all the demos, but all the demos are actually available for you to go and try out yourself. after the webinar, and it's all based in a cloud-based environment. So you will be able to easily do it. So agnostic DB, we don't have to have similar CPU RAM capacity and HDD. Again, from a database standpoint, you do not need to have symmetrical sort of nodes, but that is always a good practice to have them similar. Otherwise, from a capacity standpoint, it becomes a problem, because just imagine you lose the biggest machine on your cluster, and that though you might have like 80% of your machines available, but you lost 50% of your actual compute and hard disk capacity, right? So it becomes a problematic thing to manage it. So always try and keep symmetric nodes in terms of hard disk, RAM, and CPU. Because then otherwise, what happens is you get into what we call as a pet mentality. Oh, this is my big machine and this is my small machine. Sorry, the question from Andrew Ching is quorum-based consistency. So for us, the thing is, so long as you have the majority of the cluster up and running, it will accept the reads and writes. In fact, if you try to connect, we are a CP database. We are not an AP database like Cassandra. We are a CP database. So if in case you don't have the majority of the cluster up and running, the cluster will actually not accept any request, reads or writes. From DB migration perspective, is there any case study lab docs available for? Yes, we are YugabyteDB Voyager. You can go to our documentation. We have it available there that you can just follow and do. We have a lab for that is actually for MySQL, not for Oracle, but the procedure is exactly same. Semi-structured data like parent-child correlation. Again, we are not a document database. We are an RDBMS and a NoSQL database. So the structure is still tabular even in the NoSQL database. So we are not a document database. However, having said that, you can still store JSON-based data in this, and you can have like those complex JSON object and data types in there. About proposed UI itself, only for OLTP only or OLAP? We are an OLTP database, bordering on HTAP, I would say, but we are an OLTP database. We are not an OLAP database. Yeah. So I'll just sort of continue with this demo, and then I will quickly show you the. Is it possible to tune the DB for performance? Yes, of course. There are many switches that we have for tuning the performance. Okay, let me just continue with this quickly because I want to show you the online lab environment that you have access to. So, anyways, in this short demo, what we have is this particular instance. I'm actually connecting to the Postgres database. Here, I'm running about 5,000 concurrent connection, another 5,000, 6,000 connection here, and 6,000 connection here, and 6,000 connection here. So I will run this against the Postgres RDS. And what we will see is that this particular thing is able to succeed 5,000 connection, but here it starts failing because a single node RDS will actually limit you to about 6,000 connections. Now with Yugabyte, with my cluster, I'm able to actually run the load for like about 24,000. So I have 6,000 connections in each of these panes, and you will see that all of them, they run and they run to success, right? So this is the ability to actually run highly concurrent number of connections, plus able to actually spin up more connections. So I will pause this particular demo here, and I will just move to the next one because I am hoping that, yeah. So this particular demo, like resiliency and scale, is there in the lab environment. So let me just quickly first walk you through the lab environment that you will have access to. This is a very good demo, although this happened in the DSS also. The slide deck is actually available to you I've published it on the internet, so you should be able to actually see it. So in terms of ecosystem, if you are coming from the Postgres world, right, be sure that all these capabilities, right? Whether it is your drivers, ORM technologies, data migration tools, integration into some of the tooling, running on top of certain operating systems, all those things that are compatible with Postgres are also compatible with YugabyteDB. So that is why choosing the Postgres was very, very critical for us. So from an application developer ecosystem perspective, let me just walk you through the lab environment that we have set up for you. It's a Gitpod-based environment that you can leverage for running all the experiments with YugabyteDB without having to exhaust any resources on your system. So this is the repository where I have posted all the samples and everything that we have for this, including the link to the slides. So just remember this particular GitHub repository. The slides are also posted here. You can sort of, click through slides on this. Hopefully even the video works on this. I suppose it will. So anyway, going back. So over here, what I have done is this particular thing is also set up as a cloud-based lab environment. I'm using Gitpod for this. And the simplest configuration for Gitpod for running a multi-node cluster on a single Gitpod is through this. So there is a tool called YugabyteD, which comes as part of the package. You can actually use it to run Yugabyte on your own machine. Even if you're on Windows, you can use WSL. If you're in a Docker container, there is like a Docker run command also. And even on VMs or a Linux machine, you're able to leverage this tool to quickly run a multi-node cluster. Now, what I'm going to do is I'm just going to click on this particular button called open in Gitpod, and all these things, they will actually get executed there. And it gives you a fully functional YugabyteDB cluster, a 3-node YugabyteDB cluster on the cloud. And this is like completely free. If you've not used Gitpod before, I would highly recommend trying to see it. There are equivalent things like dev containers and github.dev. I've been using Gitpod quite well. I kind of like it. And also, we've collaborated with the Gitpod team and created the base images so that you do not need to do any installation or anything while going through these exercises. So of course, opening this takes like a couple of minutes, but once it's created, you can actually keep the workspace around for days on end. Just be sure, like, it gives you about 500 credits a month for free. So if you keep the workspaces around for longer duration, you will exhaust those very quickly. Apart from this, again, going back to the same webinar page, apart from this, there is a full set of workshops that you can actually practice yourself. The link is on the same thing. And this is like, the quick start sample from our documentation is actually here. So you launch the Gitpod and go through the motion of actually creating a local cluster and running some commands against it in this workshop. The query tuning, there was a question on query tuning. So a lot of query tuning tricks are actually well documented here. How do you actually recognize the problems? Again, we use the explain analyze command to do this. For variety of Java based microservices framework integration, this is the lab. Here you have Quarkus, Micronaut, and Spring Boot. In the inner loop, we are actually leveraging JHipster to actually create a new application from scratch. We also have Java test container. So we've actually published our container for test containers, and you're able to leverage it for integration testing for your database related code. There was a question on CDC. So this is actually a CDC sample lab where you are doing a CDC from YugabyteDB to Postgres database. And this is a CDC example where I'm streaming from Postgres of Yugabyte to the Cassandra of Yugabyte because we are a multi-model database. So going back to this I think is opened now. So off the bat, what you will see is the database cluster is already created for you, and you can go to the ports here. Now, this particular interface is going to be same for all of you. The link would be different. And if I click on this, it opens up what we call as the cluster UI. You saw this in the demo, and you're able to run this on your own. And it actually shows you how many nodes are available, what is their sort of capacity and things like those. And now if you want to actually run some sort of SQL statement, of course, like as a database engineer, the first thing we want to do is we want to run a SQL query. So for example, if you are familiar with the Postgres, /L gives you the list of databases, /D gives you the list of relationship. If you want to create a table, you just create a table like this, like books ID int primary key, right? And info, I told you we support JSON, right? So we say JSON B and we create this table. Now, having done that, this table is already created. If I go to this databases, Yugabyte, books, this is the table that we just created, and it actually shows me like how it's actually distributed across the cluster. Now, if I were to do /D here, now I can see the, sorry, /D again. I can see the books table here. If I do /D books, just like Postgres, you are able to see the structure of it and all. Now, if let me just refresh this, sorry, wrong port, I think. Yeah, so if I go to database here, I go to Yugabyte, I go to books, maybe some problem with my internet connection because I've had this issue before, but it actually shows me like this is how it's there. Now, apart from this cluster UI, we have like a couple of components, right? We have something called as master, which is a metadata server, and a T server, which is a tablet server. So like, you know, in community Slack, if you ask me, hey, I'm having this issue, typically I ask you, hey, what is the master UI showing you? So this is something that you can go back and check. This is the configuration of your cluster. If you look at the tables, this is the books table that I created. And this table has what we call as the tablets, which are basically shards. And these shards are automatically created and automatically distributed. Each shard will have what we call as a leader copy and follower copy. In this case, I'm using a 3 replication factor. So you have 1 leader and 2 followers. If you use 5 replication factor, you will see 5 of these here. Now, this is all done automatically for you. So you do not have to do it. So if you have like a particular use case or an application that you want to test out, this is the easiest way for you to actually spin up the YugabyteDB cluster and test it, right? On the same page, you have link to this on the same GitHub repository. You have link to this particular workshop where we have variety of workshops there. I would advise you to highly go try them. If you have suggestions, please put it down as an issue on the repository and I will have a look at it. We are about on top of the hour. I know we had a lot of questions. Can you share more on backup and restore? Sure. So we actually have a backup and restore capability, distributed backup and restore capability, which is actually quite well documented on our documentation. Of course, the enterprise offering, which is YugabyteDB Anywhere, has a lot more automation in terms of configuring it and then putting it on external storage like S3 or NFS or GCS or something like that. In case of open source offering, we have instructions basically to the whole backup and restore is dumping the YSQL schema, the Postgres schema, and taking a distributed snapshot. So the distributed snapshot is actually taken through a command called ybadmin. So here you basically create a distributed snapshot for a particular database, and then you export that distributed snapshot and store it outside. So the instructions for actually creating the snapshot and moving it to external storage or restoring it are all actually here. So you can actually go examine it. In fact, you can use the Git pod to actually run those experiments yourselves. Okay. Does it support multi-master kind of replication or only master standby relation? We don't have a master concept. You can read and write on all nodes in Yugabyte. You are not limited to writing only on single node. So for example, over here, let me just minimize this. If I were to go and see select star from YB servers, servers. So I have these three nodes which are running. So what I can do is the books table that I created just now, right? I say insert right now. If I say, sorry. Okay, if I say select star from init server adder, I hope I'm doing it right. I don't always get the functions correct. Oops, what did I do? Yeah, sometimes on Zoom, these things, they don't behave very well. Okay, hang on, let me try this. Let me just open up a new console, it would be easier. So here I'm connected to inet server adder. So I'm connected to .0.1, right? And if I say insert into books, right? And I say 1, and here I say ID because it's a JSON, right? So I'll just make it up. Insert into books values, right? So we inserted it here. And if I say select star from books, I get this. Now I exit it, and instead of connecting to the first node, I will connect to the second node. Okay. And I say 2. And now if I run the same inet adder command, you see I'm connected to node number 2. And now if I actually insert and I say 2, and I say 2 here, and if I say select star from books, you can see I was able to actually write from the second node. So it doesn't matter which node I'm connecting to. I'm able to read and write from all nodes. And just for completeness, what I'll do is I'll go to number 3, and I will see I'm connected to number 3. And what I'll do is I will insert in number 3 also. Right? And if I do select star from books, sorry. Yeah, I'm able to see that. So hope that answers your question of multi-master. So the question is more around the backup and snapshot. So obviously, if you have 20 terabyte of data, then and like I'm assuming that's like the complete storage of your database. So what we will do is, first of all, you have 3 copies of that data. So instead of actually transporting 20 terabyte, it would be 1/3 of 20 terabyte, which is like, I guess 6.5, 6.8 or something like that. So first thing is, what we would be transporting out would be 6.8 terabyte, correct? The second thing is, the way we actually store the data, we store it on what we call as a LSM and SSD files. So because of that, first thing that we do as part of the distributed backup is we create hard links, and then we take those hard links and export those out. Right? So that like taking the snapshot is basically creating the links, and then exporting it basically picks up all those links and puts it on an external storage. So first thing is, instead of moving 20 terabyte, because a backup is backup, right? If your data is actually 20 terabyte, we will move 20 terabyte, like 20 terabyte, which is unreplicated. If replicated data is 20 terabyte, it would be 6.8. Yeah. Yeah, you're absolutely able to send me the questions via email. I would highly encourage joining our community Slack, because we have a lot of people there from Yugabyte answering all those questions and queries there. So it's not just me, one person. So I would highly encourage joining there and asking the questions. So the link, so before I forget, so yeah, the link to the Slack channel is here. I can even put my email address if you're more comfortable asking questions there. Let me put it there. And Korea@yugabyte.com. And please scan this QR code and fill a survey form for the webinar for a free t-shirt. So it's limited to first 10. So I would say just quickly go and fill it up. And if you're somebody who wants to actually use Yugabyte in your company, feel free to actually schedule a demo with us. We have 20 USD worth of e-vouchers there to win, right? So with that, thank you very much. Thanks for joining us today. I will just check one last time if there are any questions. Oh, wonderful. Thanks. All right. Just checking last time, when you said 3 nodes for optimal performance, does it include the standby nodes or 3 master nodes? I think I've sort of answered that question, so I wouldn't answer it. Help us get. Okay, Yugabyte also creates and keeps replicas in PostgreSQL along with distributed data sharding. I don't think I understand that question from Gangadhar. Probably if you can come on the community Slack and ask the question, or on my email would be great. What logic is being used for handling the data consistency when all nodes are capable of writers? That's actually a very good question. Unfortunately, I don't have time to answer that one, but please drop me that in an email. I will definitely answer that to you. All right. With that, thank you very much. Thanks everyone for joining today. My name is Yogi, and wish you a very good evening and a great week ahead. Bye.